Alright, hello everyone. We are from TAR UMT, which is RST 271 Group 1, and I'm Chia Kin Mua. And we got another presenter who is Low Chee Sin. We'll present the next part of the presentation later on. So today we are going to present about our assignment of Fundamental of Computer Networking, which is referred to FCN. So let's go to our objective and purposes. So basically, for this assignment, we want to help a company to construct a LAN network, which is the eQuad Go Logistic Sendirian BHD. So based on their company, we found that they have 4 locations and 6 departments, where location B has the 3 departments altogether. So for the location A, there are 40 computers in total. And then for the location B, 3 departments add on together is 32 from 20 plus 6 plus 6. And then for the third largest location, which is location Donkey, is made out of 20 computers, where the last but not least, the smallest location, which is location C, is made out of 12 laptops, which is made out from 3 rooms, where each room has 4 laptops. And the printers, there are 3 printers in total, where each room has 1 printer. So as you can see, the location A and the B are highlighted in the yellow color because location A and B are the first largest and the second largest location. So therefore, there's a requirement that we need to have the 10% growth for the address. So therefore, 40 times 1.1, you will get 44. Whereas 32, you times 1.1, you will get 35.2, which is approximately 236. And for the Donkey and C, why I use the green highlighter to highlight it? Because there's a specific requirement say that location D and the C has the distance of 150 meters, which we cannot use the copper wire to connect them together. Whereas the other location has the distance between of 100 meters. Alright, so for the location D and the C is a special case that we need to use the fiber optic media. Alright, and after understanding about the objective and purposes, let's go for the method we will use to do the subnetting. So as we know, there are 3 methods to do the subnetting, which is the fixed length subnet mask, which is referred as FLSM in 2 methods, and the other method is the VLSM, which is the variable length subnet mask. And as you can see, we are using VLSM, so that's why there's a reason shown at this slide, which is referred as 3L2R. Now let's have a look why we want to use the VLSM. So we use VLSM because it has the flexibility for each of the network space, where each of the subnet we refer as a subnet has the different size, which is helpful. And then for the second part is it can improve the network redundancy and the fault tolerance, which is helpful for the administrator to do the configuration. And for the third part is the network management ability. It can improve the administrator network management. It makes them the work a lot easier. And the fourth part is the network space wastage can be reduced because just now as I say, it can improve the flexibility of network space, as each of the network space has the different size, which can be controlled by the number of hosts needed for each of the subnet. So that's why it can reduce the network space wastage. And lastly, since it can reduce the network space wastage, it can reduce the network traffic. And just now we're talking about reason of why we're using VLSM. So let's calculate it. So as you can see, there are 4 of the subnet, which are A, B, D, C, which is ordered in descending order, where A is the largest. So as you can see just now, we know that A needs 44 hosts, and then after we do some VLSM calculation, we can find out subnet masks we need for the location. And then after we found the subnet mask, we can determine the range of each of the subnet. As you can see, we use the 192.168.0.0 as our private address for the company, which is pretty safe instead of using the public address. So that's why we choose to do the 192.168.0.0 as because our host size is pretty small by comparing to the others. So that's why we use this. And as you can see, they are the first usable host and last usable host because these two are helpful for us to assign the address to the default gateway for the switch and for the printer and for the computer also. And lastly, there's a broadcast address which is also important, which indicates one of the subnet range. Same goes to the location B and the location D and the location C. So yeah. And this is the network topology. I will hand it to the Sin to continue the part. Thank you, everyone.
Okay, this is the network topology for the company. We have divided each location with different color palette like red for the location A, yellow for the location B, blue for the location C, and green for the location D. And each of the location has switches that is connected to a router which is located in location C. And since location A, B, and C are close to each other about 100 meters, so we will be using a copper cable to connect between the switches and the router. But since location D is distant with location C about 150 meters, which is out of range for the copper wire, so we were using a fiber optic cable for the connection between the router in location C and the switch in location D. And because in location B, we have two floors, which is ground floor and first floor, so we were using a crossover cable to connect between the two switches which is located in the different floors, and the switches is connected to each end device by using a copper cable as well, so that the connection is very well done. And this is the addressing table that we have designed for the subnet. So as I said it before, each of the location we have color paletted it so it will be easier to look at it since this is a small company, because the first host is used for the network and the last host is used for broadcast, so we will have a first usable host as the IP for the interface in the router, and it will act as a default gateway for each of the IP that we will assign to the host and switches, because it will need a default gateway to communicate between the subnet. And also each subnet will have subnet mask which is custom due to we are using the VRSM. So let us configure this network by using the packet tracer. As you can see here, we have done the packet tracer. The design is as close as what I have designed in the topology. And to assign a IP, we will have to click one of the PC and do the IP configuration. Like for example, if I choose the PC2 desktop IP configuration, and it will assign accordingly to the table that we have just shown you, which is 192.168.0.5. The subnet mask 255.255.255.129. And we will also need to assign a default gateway so that it will communicate between the system and also outside of their own subnet. After we have done this configuration, we are able to try to test this by using the ping. Like for example, if I ping to the subnet like 192.168.0.4, it was successfully, because it is within the range of their own subnet. So we will ping to the other subnet, which is location B, which is 192.168.0. For example, 69. It will also ping smoothly because we have tried the default gateway for them to communicate within the network. So that's all for the topology and the subnet table and also the configuration. Thank you.
Alright, before we have a good ending for this FCM presentation, I have to say thank you if you are still listening until here. So before you leave, please subscribe on my channel, which is called Programming with Jayman, because I usually like to do the game programming. Also, please subscribe to my partner who is Low Chee Sin as well. So thank you everyone.